Good afternoon, everybody. I'm just letting folks in from the waiting room as people start connecting to their audio. My name's Mark Wilson. I'm the GSE UK Region and Conference Manager. Today for this Lunch and Learn, we've got Charles from Precisely, and we're going to talk about unblocking mainframe data with AWS Mainframe Modernisation. Charles works for Precisely, and this is a Lunch and Learn, so there will be some discussion around specific products. If you have any questions, please pop them in the chat window and I will moderate them for you. And with that, I'm going to hand directly over to Charles, and I'll just keep letting people in, Charles, as they appear. But over to you, and thank you very much.
Okay, thank you, Mark. So let's start straight into the presentation for today. So our topic goes back to the session from yesterday, which was about mainframe modernization. And we talked about the various patterns, but just for those who were not able to join yesterday's session, I will just go through a very quick and short summary to refresh your memory or to set the stage for today, because we will use some of the concepts that we discussed, and we are going to, let's say, look at an actual implementation in a product that can solve the problems we discussed yesterday. So it's all about, we have data and applications on the mainframe. There is a drive to modernize these applications because you need more agility, you want to reduce costs, or you want to mitigate certain risks. And when you are going through, when you are engaging in a project to do all that, you may have many questions. Some of them are in this circle at the right-hand side of this slide. So what are my goals? How am I going to benefit from this? I have huge performance on the mainframe, enormous throughput, and how in the world am I going to deal with that in going to another environment? Is it a wise thing to do? What should be my architecture? How should I go through my test cycles? So all these are legitimate questions, and you have to bring some structure in your approach. Now, yesterday we discussed 3 different patterns to modernize and migrate applications and data. And specifically for application migration, we focused on a concept of replatforming, which means I take an existing application and I want to run it with minimal modifications, or if possible, no modifications outside the mainframe, if that is possible. Or I want to go through what we call refactoring or automated refactoring, where I look at the application code, which may be written in a somewhat older language like COBOL or PL1. And I want to regenerate that code and also modernize how that code is structured in a language that is used today, say Java or Python or anything that where I have many available developers who are familiar with working with that type of code. But the refactoring itself should be automated, because in this case we are looking at the migration patterns that are pretty much fast, right? So we are ignoring the situations where we do a manual rewrite or repurchase, where we are looking for a solution which exists in the marketplace. So application migration informs either replatforming or refactoring. And then we have data augmentation. This is about bringing data from the mainframe to another platform outside of the mainframe. And in this case, we are focusing on cloud environments. and specifically for today, a solution that works with the Amazon cloud and with the services that are already available in that specific AWS environment. Now, why would I do that? Well, the mainframe data has a lot of value, but it is kind of locked in a silo. It is in difficult to use formats. So if you want to migrate the data, you have to do a lot of additional work. But the benefit is I want to use new functions that exist in the cloud. I can immediately use those functions, but now with data that has been accumulated over decades and may consist valuable information I haven't looked into or haven't been able to look into. It could be as simple as using the cloud storage for backup purposes and archiving data. Something I do nowadays, maybe in form of putting data on tape with robots, but maybe I want this data to be available a bit faster, more online. And then, of course, I have in the cloud maybe some analytical applications to go through my data and retrieve insights. So all of these reasons can be used to can be the driver to move the data from mainframe to a cloud environment. And even when I'm moving applications with these first two patterns, an application doesn't stand alone. It operates on data. So also in the application migration patterns, I will have to migrate my data. Now, first of all, I mentioned AWS. Now, currently, we are going to talk about a solution to accomplish this. This is a solution that was created by Precisely, but it exists today on the AWS marketplace. You can go out to the marketplace, search for Precisely, and you find solutions to perform data replication, either from a mainframe environment or from an IBMI environment. So both types of platforms are supported. There are different pages or different AMIs available, but you can just use them. It works as a pay-as-you-go model. So only when you run with those applications and use the storage and so on, that is when you have to pay for it. And the marketplace AMI, it includes the software and also the documentation for installation on the mainframe and IBMI platforms. So I invite you to search for that and have a look if you want. Now, yesterday we also talked about data gravity. That is basically why are we going to use, or why do we want to use Precisely Connect CDC? That is the software that is available through these AMIs. So the first objective is you want to keep the mainframe data synchronized with services in AWS. So as soon as you have in your transaction environment on the mainframe, changes are committed to DB2, or you might even work with IMS or VSAM, but let's talk about DB2 for the moment. In that case, you want that information to be available to a service to that service you are using in AWS. The second thing that is, of course, important, if you are moving data from the mainframe, you want to have minimal impact on the mainframe environment. So if you are going to use a solution such as Precisely Connect CDC, you want your transactions to continue as uninterrupted as before. So you do not want to see delays in your transaction. You do not want to see transactions to time out because some other product is using the database tables. And from a target perspective, you may want the lowest possible latency. And that means when I am running transactions, let's say I have a bank application and the usual ATM transactions are coming in. Let's assume, for the sake of the conversation, that we want to, we want to do fraud detection. So search for any anomalies. In that case, we are running that fraud detection service or application in our cloud environment. It's looking for unusual patterns, but we do not want this to happen too late. So if the problem already happened a couple of hours ago or even later, that is not going to help me. I want to see this happening right at the moment that this is going on, so that I can immediately take actions. Now, so that is what we mean with lowest latency. We are talking about second, sub-second latency in ideal situations. So let's talk a bit about what this precisely connect CDC can do for you. It can deliver the data in the format that you need, in the style and the encoding that is demanded by the applications that need to work on it. The applications itself must be able to adjust to the workload, right? If there is a peak workload on the mainframe, it means there is a lot of data coming in. That means if that peak lasts for several hours, maybe because I'm a retail company and I'm in the December months where everybody is buying presents and it's like just crazy in the business, then this capacity should grow. But I don't want to pay for it when that peak is over. It should also shrink and adjust to the requirements at the moment. So that is what we mean with elastic capacity provisioning. And that is what running these applications in a cloud environment can bring to you. The other thing is, why do I need to bring the data to the cloud? Well, proximity of data to an application, that is what you actually had on the mainframe. So the mainframe was running applications and it also had the storage. If you would bring your application into a cloud, but it has to reach out to the mainframe every day or every time it needs data, that means you are using the network and you are introducing additional delays that is not beneficial for running your applications and getting your result in an optimal way. And also, when you bring your data to the cloud in AWS has a concept of regionalization. You can bring your data exactly to the place where you need it, where it should run. Think also about certain regulations in countries where certain types of data are not supposed to go outside of a country or outside of a region, such as the EU. Then I can exactly identify where my data should be stored. But if multiple regions need it and it is acceptable for those regions to have a copy of the data, I can also bring it to other regions if possible and within perimeters of the rules and the regulations. And finally, the time when you need it, Precisely Connect CDC is capable of doing real-time replication, or I should actually say near real-time, because there is always a very short delay between the transmission of the data and the retrieval of the data in a cloud environment. It is usually in the realm of seconds or sub-seconds even in many cases. What it also brings is the data can be stored in a redundant way. So that is what you can get by putting the data in the right target environment. And it is also a durable environment where you don't have data loss. So let's assume I am replicating data from my DB2 mainframe environment to a Kafka cluster, which is running in AWS, let's say MSK. In that case, Precisely Connect can help you to survive outages. So maybe your network is not working fine. There can be interruptions, right? We all know this situation. The product is designed to continue capturing when possible, when it has connectivity to a source. And we have taken in the design proximity to the source to make sure that capturing can continue even if the connection to the cloud environment is gone for a while. But when the connection is re-established, in that case, we have automatic recovery capabilities. So that means we are aiming for a situation where you do not have to put a lot of effort in the recovery itself, and the product makes certain that data is not lost, even during those situations where things are not running as you want. Now, we have two use cases why you want to use mainframe modernization data replication with Precisely. So the first one is for use analytics and new functions that exist in AWS. So this is not a situation where you have an existing mainframe application, but it is just, I have my data and I have this new service that is available in the cloud, and I want to run this service in order to analyze my data or to train models, AI modules. So whatever new functionality you can imagine and that is available in the cloud and where you want your mainframe data analyzed, that is this first use case. We also have the use case which is more related to what I'm doing today on the mainframe. So not really the data itself, but it is, I have something that runs on the mainframe, but I want to run it now somewhere else. I want to use a cloud service instead. And this migration should be done without downtime, without an ongoing need of an expert. Like my mainframe data can be very, very complex. They are in formats that are not commonly used on Windows, Linux, or in cloud environments. The languages that are used on the mainframe, they involve COBOL, and COBOL has certain descriptions about the format. They are called COBOL copybooks, and those are not commonly used, and they can also be very, very complex. Now, because if I need an expert all the time, I can't be agile. I'm certainly not innovating. I want to bring more modern style languages and programming methods into the play. And also, well, the resilience was on the mainframe, but I need to have that as well on the in my cloud environment, which I already discussed in the previous section. So let's go one by one through the different benefits of using data replication. Right? I can, with Precisely Connect, I have one single solution that I can use to do the integration of my data from different sources. Think about VSAM, IMS, DB2, other databases. I can prepare those sources to the correct formats that are expected for my cloud environment. I can load the data after they are prepared. Then I can do additional operations, like maybe I need to cleanse that. I need to check the quality of the data. Maybe there are certain characters that are normal on the mainframe, but are not really beneficial for my cloud applications. And I can tell you a lot of stories about that. And then I can transform and stream my mainframe data actually to AWS. That is all of that within one single solution. Now, I already mentioned the data needs to be replicated near real time. That is exactly what the solution can do to you. And it can do this for ultra high volumes. So think about this as volumes about 10,000, 50,000, 70,000 transactions per second ongoing. That is what you want a replication product to deal with. Now, in terms of optimized processing, we want to use the database logs. And the reason for that is if we have to do delta processing on the mainframe against full sets of data, extract complete tables where maybe only 1% of the data has changed, we are going to use the network and other resources in a very bad way. So reading changes from the database logs, the redo logs, the transaction logs, or however you call them, that will reduce the amount of data you have to handle significantly, while at the same time you can have all the modifications in one go. Of course, you need to, while you are processing your data, you want to get rid of specific encodings that are used on the mainframe, let's say EBCDIC. More common, certainly if you go towards a Kafka target, the encoding should be Unicode. So the translation should happen in transit, on the fly. And you certainly do not want to stage extra copies of the data to do all that work. It's just adding additional weakness to your solution because, well, you have to remove those copies after they are done. You have to check that they are actually removed. You don't want to sit them around. You need extra storage for that. And so there are lots of things that you want to do against the data while it is in transit, in memory, not landing on disk, before it is written to the final target. Now, in terms of transformations, I already mentioned the difficulties of certain formats on the mainframe. Copybooks have concepts such as occurs and occurs depending on. You can see it in modern style as an array or a variable array, where the length of the array depends on some other value that is in the same, hidden in the same data. So COBOL can handle that. The Precisely Connect can also handle occurs depending on, and it can also handle things like redefines. So you remember the situation where the same structure, the same data structure was used, but at some point a field becomes outdated. Well, it was very common that that field or combination of fields even was used for a completely different purpose, even another data type or set of data types. That is called a redefine. So you have the same record length, but somewhere inside, part of that structure has changed, and it is now becoming different fields with different data types. Those redefines are very common. They happen, and they can cause a lot of problems. So your replication product should be able to cope with that as well. And Precisely Connect is very much capable of that. Finally, I want to point out the concept of variable length records. If we talk about open systems, and that includes everything that runs in the cloud, we are used to record termination. There is a specific character at the end of each record which signals, well, this is the end of the line, this is the end of the record. line feed, a carriage return line feed on Windows, the line feed on Unix and Linux. But on the mainframe, we have variable length records without such termination. It just at the beginning there is a number, let's say an integer, that says the next record has this amount of bytes, and every single record starts with a different or maybe the same number, but there is this number. And so these variable length records must be, they are very common, and you have to work with them as well. So I talked a lot about the required and desired capabilities of a product. Now, what components does AWS Precisely Connect have? The first component, it makes sense, right? We have a capture agent. So this is the agent, this is the entity that sits on the mainframe and is responsible for monitoring the logs and capturing all the changes. So it checks the logs, and as soon as a transaction gets committed, it will take out that information. It will put it in transient storage, which is memory based. And then there is this publishing agent, which also sits on the mainframe. It is actually part of one and the same entity that runs. That publisher is responsible for sending out data to all the targets that have subscribed to this information. So we have a site that is capturing, and we have a site that is publishing in this process. And they can run more or less independent of each other, right? Because imagine that the connection between the mainframe and something that sits outside of the mainframe, I'll come to that later, is not available. This publisher cannot do its work, but there is no reason why the capture agent should not return, consume the differences, the changes against the database. It can continue to do so and put information in transient storage, even when the publisher cannot send the data out. Of course, you can imagine this transient storage. It is sized. It has a certain there is a certain amount of storage that it can allocate. So at some point there will be an end to it. Then it cannot add more into this storage in memory. Well, transient storage is basically memory mapped, so it can spill to disk. And you can also say there is so much disk space available to hold on to transactions until this problem with the publisher on the publisher side is solved. So this is what runs on the mainframe. And as you can imagine, everything that runs on the mainframe must be lean and mean. It shouldn't consume any cycles, resources, or as low as possible. So that is why the capture and the publisher are just responsible for collecting the information and sending it out. There's nothing about all these other changes that must be done, because that is the responsibility of the apply agent, which is a process that runs in the cloud, on a virtual machine, or on a physical machine, on a Linux or Windows system. Normally it's Linux. And it is receiving the information from a publisher. And the apply engine is actually the entity that does all this heavy lifting. It makes the changes to the encoding. It changes the record formats to something that is appropriate for your target database or for Kafka, maybe Avro or JSON. And finally, it is connected to this target, and it sends out the data on one or more simultaneous worker connections, depending on how much data you need to write to target. So that concludes effectively the whole data pipeline, capturing, publishing, and applying to target. Where capturing and publishing is lightweight on the mainframe, applying to target does all the necessary work and writes to my final destination, which can be Kafka or a relational database, say Postgres. I'll come to the differences in a moment. And of course, you see one more process, which is called the controller daemon. The controller daemon is very lightweight, and it has only one responsibility, actually two. It authenticates all connection requests that come in from the Linux side, from the apply engine, and it makes certain that that this specific request is properly authenticated. So there is an authentication handshake that is handled by this controller daemon. And if this apply agent does not authenticate itself with the correct information, the connection is denied, as it should be. If it can authenticate itself, that means this specific apply engine is able to connect to a specific publisher on the mainframe. So the controller daemon then migrates that socket to the agent. And then there is a second set of handshakes possible to guarantee encrypted communication between the publisher and the apply agent. So the controller daemon is actually the gatekeeper, and all the details, who is supposed to make connections, who is allowed to do that, to maintain access control lists, that is all handled on the mainframe itself. So the mainframe administrators and the DBAs, they maintain and keep full control of where their data is allowed to go and in what format, if it is just unencrypted or if an absolutely a secure encrypted connection is required in this case. And then finally, of course, the product comes with a set of utilities, because each of these agents and controller daemons, they are based on configuration files. And these utilities are used to build out those configurations and to manage and control the capture, the publisher agents, and the engines, starting, stopping, pausing, resuming, and also checking the state and the actual details of these pipelines. I want to know at a very granular level what information is sent through the pipelines in total, but also for each and every individual table I am replicating, I can maintain information. That can all be retrieved by those utilities, and the result of those of that information can be put in a file and subsequently processed by environments that are used for monitoring. You can take the information from these files and feed them into environments like Splunk or ServiceNow or in other control environments. Amazon has this type of control as well, which is integrated with the solution. So independent of how you want to monitor your environment, this information can be made available and it can be put on dashboards. Now, so far I haven't mentioned the exact architecture, but I have informed you about information how this all works. So on the mainframe, for vSAM, DB2 or IMS, or for IBMI, which is also part of the solution, there is a component that runs on the mainframe. So we have the capture publisher. And then outside of the mainframe, we have Precisely Connect running in the cloud on an EC2 instance, let's say. And from there, it can push the data to subsequent targets. In this case, we highlighted Amazon MSK, and that is for a specific reason. Because imagine the enormous throughput you find on the mainframe, the transaction rates that are just well, incredible. And so as a target, if you want to replicate the data constantly and not get behind the curve, you need an environment that is capable of absorbing in parallel, well, the same quantity of data. And MSK, Kafka, or streaming targets are designed to do that. So from there on, you can have subsequent downstream targets, my relational databases, where I can put the data. You can use sync connectors, for instance, to consume the data and put them into a relational database. So that is what you see here in this specific design, how we sit between the source and the target. There is one more thing I didn't mention when I was talking about the architecture with a component sitting in a cloud environment, the apply engine or replication engine, as we call it. There is always a situation where an apply engine is stopped or the machine is stopped, maybe for maintenance, maybe something happened, I don't know. But let's assume my apply engine is not available. It died. It was now when an apply engine restarts, it is basically stateless. It doesn't know anything. The only information it has is what you put in that configuration file. It says, hey, connect to this controller daemon on the mainframe, and here is the IP address and the port. Authenticate yourself with this information, and then ask for a connection to a specific publisher. More it doesn't know. It doesn't even know what it has done during its previous life. It's stateless. It just starts as a brand new engine. And so how do I start again from the point where things left off? What was the last transaction that I have successfully replicated to my target? Well, all that information is maintained in the safest possible environment. It is maintained by the capture publisher combination on the mainframe. So that capture publisher knows exactly what was the last confirmed transaction by this replication engine. So it will be responsible to inform the new apply engine what it has to do next. And so that is part of the automated recovery. Now, of course, you can also say, yeah, but maybe I have situations where my database is under maintenance or I stopped my capturing. Well, the capture also has information about persistent information about what it has captured last time. The position in the database log, it has that pointer and it is available on disk. So when you restart that capturing, it will look for that information. It will go to the log, assuming it is still available and hasn't been archived or is lost for other reasons. But as long as that database log is still there, it can go to that location and start reading through the logs. Actually, it will go a bit earlier and just go through a little bit extra information just to make sure that it is not missing transactions that were already ongoing halfway at the moment that the capture agent was stopped. That is a technical detail, but it is to make certain that we are not going to miss information, because that would be the worst thing you can imagine. Now, one other thing I haven't mentioned, this is all about replication. So replication of changes. But every time you want to populate existing data in a target, there is a moment where you have to do an initial load. And Precisely Connect can deal with that situation. It can do an initial load and then continue with change data capture. It can even start an initial load while transactions are ongoing against the same table it is loading at that specific moment in time. And it will, of course, first do the initial load, make sure that all the original data is on target. And then it will apply the changes it had accumulated during this initial load for that specific table. It will apply those to target as well. So at this point in time, we have a consistent copy of the data, which is exactly up to date. And from that point onwards, it will continue to replicate new data. So new changes, inserts, updates, and deletes will constantly flow on this pipeline to keep the target perfectly in sync with the source. And it is important to understand that this initial load is designed to not cause anything related to transaction timeouts because we claim too much of the source tables. Think about lock escalation, where if you do a select star from table, DB2 might decide to give you a table lock. That is something you do not want to have. So you can specifically work with this initial load mechanism to avoid that situation. Another thing that you do not want, besides the table logs, is just too much of let's say a resource or capacity causing too much resource consumption against the source table. Those things should be avoided as well. So we are really taking care of. And last but not least, if we do an initial load, there is also there are transactions going on. So those transactions take priority. We want to handle those transactions. And even if it means the initial load takes a bit longer due to that, because we have to switch between handling the CDC and the initial load requirements. CDC takes priority, but the initial load will get through. And eventually, when all the data is on target, including all the changes, at that point, we have a consistent target again. So that is one of the specific features of Precisely Connect CDC that you can bring to the table in order to handle the complete set of requirements for a data replication exercise. So I want to see if there is anything in the chat, if we have questions. So, yes, so I see a question. When you say low latency in replication, I would like to know what is latency in seconds to replicate real-time data in cloud environments? Also, do you use DB2 logs? The answer is yes, we use DB2 logs. If you are running DB2 in a multi-member sysplex setup, where DB2 runs on different LPARs, of course, there are logs on all these LPARs, but they are merged through what is called the coupling facility. So that makes certain that even in those kinds of setups designed for high performance, we will be able to process the data in the correct sequence. So Golden Gate Kafka channels for replication or any other. Let me see what is meant with that real time. I don't Golden Gate Kafka channels for replication or any other. I'm not quite sure what the question is. Maybe it should be rephrased here. Latency, of course, the question is how long is a string? But let's say we have seen latencies between on-premise DB2 in a mainframe towards a Confluent Kafka cluster running in AWS Cloud, which is sub-second. So that's what we can see in well, situations where the network is optimal and running the connections to Kafka are available, and we have good connection to DB2. So that is one of the possibilities. In the final diagram, you showed MSK as a target. Can you replicate directly into Amazon RDS? The answer is yes. Amazon RDS has several flavors. So we can replicate directly with an apply engine in MySQL, RDS MySQL, RDS Postgres, RDS Oracle. And what is not mentioned in this slide is RDS DB2. So, oh, that's the second question that came in. But last week or 2 weeks ago, RDS DB2 was announced as the next supported RDS target in AWS Cloud. So the reason why we work against MSK is basically the capability to work with these ultra high volumes of changes we encounter on the mainframe. If you would go against a relational database, if we apply transactions against a relational database, they must be executed in the exact same order in which they were applied. If you would try to parallelize that information, we have to wait for acknowledgement from the database. Yes, I received your insert before we could send the next change, which could be an update to that same insert we have just done. If those things against a relational database would arrive out of order, you would have an issue, because then at some point you would have created an inconsistent copy at the target. So there is a difference in terms of the throughput that you can run against MSK or against a relational database. And that is due to the nature of that database itself, the ping pong effect with the acknowledgement that we have to wait for. Of course, we also have to wait for acknowledgement from Kafka, but they can be batched. Kafka is different, and it can handle those enormous transaction loads. Now, if you want to reconstruct a specific transaction that arrives in my Kafka environment in the cluster, it sits in, let's say I have changes for a specific transaction and I've written them to topic. Is there a way I can find out how those changes were applied? What was the transaction that was responsible for it? And even what was the sequence within the transaction that those changes were applied against the original source? Yes, it is possible. As we are not only replicating the data, but we can also add some further operational metadata to each and every message that we write to Kafka. And that can be a message corresponds to, let's say, a changed record in DB2. So we can add information about the name of the source. Where did it come from? What was the table name where it came from? What was the transaction ID that was used for this specific transaction? What was the sequence number within the transaction? All that data can be added to individual additional fields. And I'm not talking about the data itself, because of course we can replicate that, but this is extra information. So consumers from those Kafka managed messages have access to that information, and they can reconstruct exactly what happened against the source. At least that knowledge can be made available. Do you support RDS DB2? Yes, that question I already answered. Since 2 weeks, that is target is also available. And does this product support production databases and applications which run in high availability mode? Yes, and so it can be high availability mode for the mainframe parts, so the capture publisher I was talking about, you can have a capture publisher which runs on an LPAR, but if that LPAR becomes unavailable, you can have mainframe automation that can restart this capture publisher on another LPAR to take over. What would they have in common? That is some sort of storage, the transient storage and the configuration files I spoke about. Those must be available on ZFS files that are available to both these LPARs where these capture publishers are going to run. So standard failover capabilities from the mainframe in terms of automation can be used for that part. And on the Linux part, it is even simpler because I already talked about this completely stateless apply engine. You can just start an apply engine. It doesn't know about the history. It doesn't have to maintain a history because it will learn that later on when it is connected to the mainframe. So you can even lose a complete virtual machine where that apply engine is running. You can bring it up on a new standby virtual machine. You can activate it. It will connect to the mainframe and it will restart as if nothing happened. And of course, if you work with Kafka, Kafka has built-in high availability capabilities in terms of data redundancy and duplicate copies of your data. So that's all guaranteed. So the answer is yes, the product is very well capable of running in high availability mode. And I think that is the final question I have seen. So is there anything else that you would like to ask?
We've got 8 minutes left, Charles.
8 minutes.
Yeah, we've got 8 minutes. So I'd say, giving folks a chance to ask a question or get a bathroom break in before the next one. I know which one I'd choose.
Well, I can hang on and wait for 8 minutes just in case someone remembers or thinks, oh, you failed to explain this. But yeah, so besides that, I can just give some information about Precisely and maybe, so Precisely is a company that is really a leader in the industry. We have many customers around the world. Servicing 99 of the Fortune 100 customers, and well, close 2,500 employees. That is the latest number, but probably still growing. And of course, you can see we work with many different sorry, my voice is going to break down, but with many different companies as well as technology partners, Amazon, AWS is mentioned. So that's basically something about Precisely itself. And finally, maybe next steps, if you found this this very informative and think, hey, maybe I need to learn a bit more about the product. I want to see it in action. You can request a demo or have another conversation with experts. Maybe you will get connected with me. And we can also expand on specific, let's say, requirements that I brought to the table and say, well, this is what I would like to have. Is that something that that you can do as well? And just let us know what you think.
So, Charles, thank you very much for that very informative session. Lots of interesting information there. I'll just ask the folks who've attended the session, if you would please leave us feedback. You know how to do that via the bring your own agenda or the QR code that you can see that Charles has got. You can scan that. Thanks for the feedback, Sandeep. Charles, thank you very much. A couple of weeks after the conference, this will all get posted online once we've edited the rubbish out at the start. But again, Charles, thank you very much.
Okay, thank you, Mark, and thank you all who attended this session. and I hope to hear more from you guys. Thank you so much. Bye.